let's have this playboy model to present us our example. So we have point P here in this dumbbell here, and we have point Q in this shoe. So let's make a transformation. Let's make a translation for units to the front. 1, 2, 3, and 4. So now we have point prime P, and we have point Q prime. So they are the same measurements. This presents that this a translation is an isometry because the measures are kept and remain the same measures. And 7.4 theorem 7.4 explains it. The translation is an isometry. Now let's have an explanation from Pérez for the reflections.
You can have a translation if you have two rotations over parallel lines. Here's our reflection.
You know, vectors are recognized for its magnitude and size. We recognize a vector for an arrow. We symbol it with an arrow like this. So a vector has an initial point and a terminal point. The initial point is where the arrow, where there's no arrow. So in this case it will be here. And the final point or terminal point is here where the arrow stops. So you know both points of it, and the vector is represented by a component form. The component form uses a coordinate to represent it. But it's not put into a parenthesis, but into some set of signs like this one. The component form is related to the slope. Component form represents how much units it goes up or down. It displaces itself up or down from the initial point to terminal point, and how many units it displaces from left to right or right to left. Okay, now let's have an example of a vector. This is a vector shown in here. So the vector is measured by how many units it goes up and how many units it goes to the right or left. So we write the component form according to this. It says it goes 2 units to the left and it goes 1 unit up. So the component form will be written first. You write the number of units it moves to the left or right horizontally. So it will be 2, and then you write a comma. Then you write a 1 because it goes up. If it will go down, it will be a -1 because it goes down.